All right, so last section in chapter 8 is being able to solve rational equations. We're going to kind of pool all the things we've learned in but being able to simplify rational expressions and being able to solve for the variable. These examples here for A and B, they want us to be able to use cross multiplication in order to solve for the variable. What that'll do is that it will eliminate um, any fractions, and then we can solve our variable. So just like cross multiplication, we do multiply these two values and multiply these two values. But you have to remember that it's going to look like 11 times x minus 2 equals 7 times 2x minus 10. So you have to make sure that you use a distributive property or use FOIL depending on um, what kind of values that are given in any specific problem. So here, if I distribute, it'll be 11x minus 22 equals 14x minus 70. And I'm going to get my x over to the right hand side. So if I subtract 11x to both sides, I'm going to get 3x here, and it's going to equal, and if I add 70 to both sides, I'm going to get 48 on this side. So now if I divide both sides by 3, my x here is going to equal 16. Okay? If I look at B, again, I'm going to cross multiply again. This value here, this value here. So now I'm left with x times 2x plus 5 equals, and 1 times anything is just going to be its whatever it is. So I'm just going to leave it as 11x plus 8. So if I distribute that right hand side, I'm going to leave with 2x squared plus 5x equals 11x plus 8. I'm going to try to get everything on one side of the equal sign because I have a quadratic here. So now I'm going to have 2x squared minus 6x minus 8 equals 0. So from here, I can divide, or I can factor out a 2. So I can go 2 times x minus 3x minus 4 equals 0. And now I can factor out or use reverse FOIL. So I can go x and x plus minus, and this would be a 1 and a 4. So if I can have x equals negative 1, I can have x equals 4. Make sure you check your solutions to see if they work, and these ones do. Also, they're going to ask you we're going to be able to use rational expressions through real life situations. We have a story problem here where we have a sightseeing boat travels at an average speed of 21 miles per hour in a nearby calm water lake. in nearby calm water of a large lake. All right, the same boat is used for sightseeing in a nearby river. In the river, the boat travels 3.1 miles downstream with the current in the same amount of time it takes to travel 2.6 miles upstream against the current. What they want to know is what is the current of the river. So going back to some formulas here, we know that distance equals rate divided by time. We know that we know the distances are different and the rates are different. The only thing that's the same is, well, actually the only thing we know that the rate's the same, but we need to find out what we need to solve for t because we don't know how much time it took. Well, yeah, that's the only thing that's the correct correct variable. T is the only thing that's the same, because here we can say that it's in the same amount of time, right? So T has to be the same. So what I'm going to do is I'm going to solve for T for this. So I'm going to multiply T to both sides, which cancels this out. So I'm left with TD equals R. And then if I solve for T, I'm going to have T equals R divided by D. So we know it's the same amount of time, but for the one that went downstream, we know that it both went 21 miles per hour plus X, whatever the speed of it is going downstream, and we know that the distance was 3.1 miles. It equals 21 minus X, because it was divided by 2.6 miles. So from here we can cross multiply. So I have 65.1 minus 3.1x, that's what I get right here, equals 54.6 plus 2.6x. So I'm going to get my constant values on the left-hand side. So if I subtract 54.6 to both sides, I get 10.5. And if I add 3.1x to both sides, I get 5.7x. If I divide both sides by 5.7, I get 1.84. And that is the current of the river. Last thing they want us to do is be able to solve rational equations. So this means that we're going to use the steps that we did for adding and subtracting rational expressions, and then at some point we'll be able to use cross multiplication in order to find our answers. So for A, I have 2 halves plus 3 over x equals 3. So what I'm going to do for this one, I'm just going to want to find the least common multiple, which will be 2x. So what I'm going to do is I'm going to put 2x to each of them. So I'm going to go 2x over plus 2x equals 2x. So I need to add an x to this numerator. I need to multiply 2 to this one, so that leaves me with 6. And I need to multiply 2x to this numerator, so that gives me 6x. So if I multiply it out, I get 7x plus 6, all divided by 2x, equals 6x divided by 2x. Here I can cross multiply, which then gives me 14x squared plus 12x equals 12x squared. I can divide both sides by 12x squared, which leaves me with 2x squared plus 12x equals 0. I can factor out a 2x here, so I get 2x here, and it leaves me with x plus 6 equals 0. That means that x could equal 0 and x could equal negative 6. But it can't be 0 because 3 divided by 0 will give me an undefined value, so the only one that works is x equals negative 6. So for B, if I look at it here, the only looks like here's going to be looks like x. So let's see here, what would be least common multiple here would be, I'm just going to put x here, so then it'll be 12 over x, and then what, x plus 7. This will be x up here, equals x over x minus 12 over x. So now I have 12x over x squared plus 7x equals x minus 12 all divided by x. If I cross multiply, I get 12x squared equals, I got x cubed minus 12x squared plus 7x squared minus 84x. So we got common terms here, so I got 12x squared equals x cubed minus 5x squared minus 84x. If I subtract 12x to both sides, so I get 0 equals x cubed minus 17x squared minus 84x. I can factor out an x here, so I'll leave with x squared minus 17x minus 84. I can use reverse FOIL. So these are plus 4 and minus 21. And that means x could equal 0, x could equal negative 4, and x could equal 21. We know that it can't equal 0 because if we put it back into the original equation, we know that it's undefined. So, and what does work is x equals negative 4 and x equals 21. So here, what I'm planning on doing, like, let's rewrite, I want to rewrite this to let you know that this could be x plus 1 and x minus 1. Just so no confusion. What I'm going to do now is find the least common multiple, which will be x plus 1 times x minus 1. So what I'm going to do here is I'm going to multiply each side by the least common multiple. So I'm going to go 7. I'm just going to put x plus 1 and x minus 1 here, divided by x minus 1, minus 5 times x plus 1 over x minus 1 here. And this is going to equal 6 over x plus 1 over x minus 1. And this is the same thing, so these get canceled out. This gets canceled out. So I'm left with hold on a sec. Sorry about that. Actually, what I've done is I've done something incorrect. Let me erase this. Apologize. It's my fault. What I need to do here is I need to find, again, the least common here was, I said was, what, x minus 1, wouldn't it be? Yeah. So from here I can go 7 times x minus 1 over x minus 1 minus 5 over x minus 1 over 1, and this equals 6 times x minus 1 over x plus 1 over x minus 1. Yeah, that's better. Sorry for the mix-up. Cancel this one, cancel this one, cancel this one, cancel this one, so I'm left with 7 minus 5 plus 5, and I just distributed it, and then it equals 6 over x plus 1. This is an x right here. So now if I combine like terms, I get 12 minus 5x divided by 1, which equals 6 over x plus 1. I can just cross multiply, so I got 6 equals 12x plus 12 minus 5x squared minus 5x. I have like terms here and here, so I'm going to 6x equals, so I'm put negative 5x squared here first, plus 7x plus 12. Set this side equal to 0, so subtract 6 to both sides, so I get negative 5x squared plus 7x, and it would be plus 6. But I like to have my lead coefficient to be a positive number, so I'm going to multiply all this by negative 1, so I'm going to do that here. So now I have 0 equals 5x squared minus 7x minus 6. So here I can go 5x, x here, and this will be what, plus 3, and this one's going to be minus 2. So x could equal negative 3/5, and x here equals 2. Sorry about the mistake. And solving for d, I know that the least common multiple on that side would be x, so I can go 10 over x plus 3x over x equals x plus 9 all divided by x minus 4. So I go 10 plus 3x divided by x equals x plus 9 over x minus 4. Cross multiplying, which gives me x squared plus 9x equals, that's if I did this. And then the other side is going to give me 10x minus 40 plus 3x squared minus 12x. I have common like terms here, so I got x squared plus 9x equals, I'm going to put 3x squared here minus 2x minus 40, subtracting my x squared and my 9x to both sides, so I get 0 equals 2x squared minus 11x minus 40. I can use reverse FOIL to factor this out, so I got 2x here, x here, and I'm left with a plus 5 and a minus 8. So x could equal negative 5 over 2, and x here could equal 8, using the zero product property. And that is being able to solve rational equations. Hope this helps. Till next time.